Have you ever wondered how the big cloud companies manage to provision thousands of servers with what looks like a single command? Well, you're about to find out. Today, we're deconstructing the API that makes it all possible, Redfish. Let's dive right in. So first, let's just set the stage here. We're not talking about managing one or two machines in a rack. I want you to imagine thousands, maybe even tens of thousands of them. How in the world do you command, monitor, and update that entire army of hardware without going completely crazy? That right there is the fundamental challenge that Redfish was built to solve.
So what was the industry's answer to this absolutely massive challenge? It's a standard called Redfish. Let's start with the most basic question of all. What exactly is it?
At its core, Redfish is a standard API. But a better way to think about it is like a universal translator for all your data center hardware. It's one single, consistent language you can use to talk to servers, storage, networking gear, you name it. And it was designed from the ground up for the incredible scale of today's data centers.
And to really get why Redfish is such a big deal, you gotta look at where we came from. The old way, using standards like IPMI, was, well, it was a nightmare. You were dealing with these clunky, binary protocols. Even worse, every vendor had their own special secret sauce, their own proprietary extensions. That meant the automation script you wrote for one brand of server was totally useless on another. Redfish just throws all of that out the window. It's built on the same simple, powerful tools that run the entire internet, HTTP and JSON. It's open, it's human-readable, and it was made for automation from day one.
Now, what's really fascinating here is why this change was so desperately needed. Why did the whole industry have to come together and build a brand new standard from scratch? The answer, in short, is the modern cloud-scale data center. We hit a point where we needed to automate everything. We also needed it to be secure by default, which is why Redfish makes modern TLS encryption mandatory. That's the same security, by the way, that protects your credit card info when you shop online. And absolutely crucially, we needed a consistent data model, so a script written for one vendor's server would just work on another's. Redfish delivers on all of this. Okay, so how does it all work under the hood? Well, if you've ever done any web development, this next part is going to look incredibly familiar to you. This is really the key insight to grasp. Redfish is just a RESTful API, and RESTful is just a fancy way of saying it's a predictable, easy-to-use web API. The only real difference is what's on the other end of that connection. Instead of asking a website for some data, you're asking a server's management controller for its internal temperature, or you're telling it to reboot. And this just shows you how simple it is. Redfish uses the same standard HTTP methods or verbs that you already know. You use a GET to read information, like checking on a server's health. You use patch to change a setting. You use post to create something new or to kick off an action, like a reboot. And you guessed it, you use delete to remove something. It's simple, it's predictable, and it's incredibly powerful. And the data you get back? It's just JSON. It's super easy for computers to understand, but it's also easy for you and me to just read. Look at this example. You can see right away we've created a new user session. You don't need a special decoder tool. You can literally read the conversation happening between your script and the hardware. And that makes developing and debugging your automation so much easier.
All right, so we've got the basics down, but the real magic of Redfish, the stuff that makes it work in the real world, lies in a few power features designed for the messy reality of data center operations.
I mean, think about it. Some tasks just take a while. Updating a server's firmware, for example, can take several minutes. You can't have your automation script just sitting there frozen, waiting for that one request to finish. At scale, that would be a complete disaster.
So, how does Redfish handle this? This is where it gets really clever. It uses what's called an asynchronous model. Your script sends the request to start the long job, and the server immediately replies, "Yep, got it," and gives you back a link to a special task resource. Your script can then go do a bunch of other things and just check back on that task link every now and then to see how it's going. It's a really elegant, non-blocking solution that is absolutely essential for large-scale automation. Okay, here's another common headache. Let's say you need to update the permissions for 10 different user roles on a system. Are you really going to send 10 separate API calls, one after another? That's just slow and really inefficient. Of course not. Redfish has an amazing solution for this called a deep patch. This lets you send a single request to a whole collection of things, like all the user roles in this example, and modify all of them at the same time. This massively cuts down on network traffic and makes your automation scripts way cleaner and a whole lot faster. So let's tie all of this together. We've seen the modern design, we've seen the web-based language, we've seen these power features. What's the ultimate payoff? What does this mean for someone who's actually managing a huge environment? Well, the payoff is solving this problem. We're not talking about managing a handful of servers. We're talking about managing thousands, even tens of thousands, as if they were one single cohesive system. This is a scale that is simply impossible to handle with old-school, manual, one-at-a-time methods. You absolutely have to automate. So why does all this matter to you? Because with Redfish, you can automate pretty much everything. You can finally plug your hardware management right into your existing DevOps and CI/CD pipelines. You can write one script to manage them all, no matter who made the hardware. It lets you build infrastructure processes that are secure, that are repeatable, and that can truly scale. And you know, there's a line from the official specification that I think just perfectly captures the soul of Redfish. It's saying that the addresses for each little component, a specific fan, a specific memory stick, have to stay the same, even if you reboot the server. And that stability, that predictability, is everything for automation. It means the script you write today won't suddenly break tomorrow. It is the rock-solid foundation that reliable automation is built on. And that brings us to our final question for you. Redfish isn't just another protocol. It represents a totally new way of thinking about your infrastructure, thinking about your hardware as code. It provides the toolset for true API-driven automation, all the way down to the bare metal. So the real question is your infrastructure ready for that future?